There's this piece of tech that's so tiny you could literally balance it on your fingertip. But, and this is the crazy part, it's absolutely essential for everything from life support machines all the way to your morning coffee. Today, we're going to unpack the XGZP6827D. It's this tiny but mighty pressure sensor that, well, it pretty much quietly runs our world. So let's kick things off with a little puzzle. What do you think a medical ventilator, a wearable device, and a coffee maker all have in common? I mean, think about it. A life-saving machine in a hospital, the fitness tracker on your wrist, and the gadget that makes your morning espresso. They seem like they're from completely different worlds, right? But they all rely on one secret, super important little component. And there it is. The answer is this unassuming little guy, the XGZP6827D pressure sensor. This is the unseen hero that makes all that precision and reliability possible in all those machines. It's just amazing proof that some of the most complex tech can come in the smallest packages. So just how versatile is this sensor, really? Let's take a look at its secret life, following it from the most critical medical settings right into our own homes. First up, the medical field, where, precision is everything. This sensor is right at the core of ventilators and CPAP machines, controlling air pressure with pinpoint accuracy to help people breathe. It's also inside blood pressure monitors, oxygen concentrators, and even drug dosing systems. Places where getting the pressure exactly right can literally be a matter of life and death. What's incredible is that the same basic technology that keeps someone breathing in a hospital is also inside stuff we use every single day. In a drone, it's measuring barometric pressure to hold a perfectly steady altitude. In a high-end coffee maker, it's making sure you get exactly 9 bars of pressure for that flawless espresso shot. It's even measuring water levels in washing machines and suction power in vacuums. It is, quite literally, everywhere. And its reach goes even further, into some really demanding environments. In industrial settings, this sensor is a total workhorse. We're talking monitoring HVAC systems for efficiency, measuring liquid levels in massive tanks, and feeding critical data to automated factory processes. It's even tough enough for cars and trucks, which just goes to show it can handle pretty much any job you throw at it. Okay, so we've seen what it does, which is a lot. But how does it do it? It's time to peek under the hood and see what makes this tiny sensor tick. We're going deep inside the silicon. At the very heart of this thing is what's called a silicon piezo-resistive die. Now that's a mouthful, I know. It's just a fancy way of saying it's this tiny sliver of silicon, and when pressure makes it bend, even just a little bit, its electrical resistance changes. That change gets read by what's basically a tiny specialized computer right on board, an ASIC, or application-specific integrated circuit. This little brain acts like a translator, turning that physical pressure into a nice, clean digital signal that other electronics can understand. And the whole package is protected by this tough plastic case. And that internal design translates directly into some seriously amazing performance. Just look at that 24-bit ADC resolution. That means it can tell the difference between over 16 million different levels of pressure. That's the kind of incredible subtlety that allows a ventilator to deliver the perfect breath. Oh, and it's tough too. It can handle sudden pressure spikes up to 2 times its rating, so it's reliable even when things get a little chaotic. But if there's one number on this list that really, really changes the game for modern electronics, it's this one: 6 microamps. I mean, that is an insanely small amount of power. To give you some perspective, that's just a tiny, tiny fraction of the power used by a single little blinking LED light on your internet router. And it's this incredible efficiency that makes it an absolute hero for battery-powered stuff, like wearables and remote IoT sensors that need to keep running for months or even years on just one charge. All right, so we know it's powerful and super efficient. But how does an engineer or a developer actually get that pressure data out of the thing? Let's take a quick look at how you actually communicate with this sensor. So the sensor speaks a really common language called I2C. That's I squared C. You can think of it like a super efficient 2-wire digital conversation. One wire is like a metronome, keeping time for the signals, and the other wire sends the actual data. It's a standard that lets the sensor easily send its super accurate pressure and temperature readings to the main computer in pretty much any device you can think of. And for a developer, hooking it up is really straightforward. You only have to worry about 4 main pins. You got your power, your ground, and then those 2 I2C lines for the clock and the data. The whole design is all about making it as simple as possible to integrate into a project. What's really clever about its design is that it gives developers a choice. You have to make a bit of a trade-off between power and performance. You can use what's called NOR, or on-demand mode. Here, the sensor just sleeps until the main computer says, hey, I need a reading. This saves the absolute most power possible. But if you need constant updates, you can use CYC, or cyclic mode, where it automatically wakes up, takes a measurement, and goes back to sleep, all on a set schedule. So, after seeing where it's used, the tech inside, and how it all works, what's the big takeaway here? What's the bottom line? Well, it all boils down to this really powerful combination. It's accurate right out of the box because it's already calibrated for temperature changes. It gives you a clean digital signal that's easy to work with. It barely sips any power. It can measure a huge range of pressures, and it's designed to be affordable for mass production. That specific blend of features is exactly what makes it such a game changer. The company's own slogan for it really says it all. Always perfect under pressure. And, that's not just some clever marketing line. It's really a promise of the reliability and precision that engineers have come to count on, whether they're building a life support machine or a coffee maker. When you get right down to it, this tiny piece of silicon is one of the fundamental building blocks of our modern world. It's this unseen force that enables innovation absolutely everywhere you look. And that leaves us with one final and pretty exciting question. Given all its power, precision, and efficiency, what incredible new technologies is it going to empower next?